Okay, let's start today's lesson. This new one, binomial expansion. Binomial expansion. Write down topic, binomial. Binomial expansion, pure lesson. Definitely, question number 12 or part A question is very simple question that comes with series. Question number 12. Okay, binomial expansion. And here the pool, binomial expansion and permutation and combination and series. Those three come with question number 12. And part A, there can be another one question for those three. Okay, then all together, surely there will be 17.5 marks in pure paper. 17.5 marks in pure paper. Okay, let's start. Let's start binomial expansion. Consider binomial. Binomial with two terms. X plus or minus y. Here binomial. Then x plus or minus z we call trinomial. Binomial and trinomials. We're going to discuss how to simplify and what are the relations with binomials and trinomials. Okay, when you consider a binomial, x plus or minus y with power n. Here we say n, positive integer. It has expansion. Has expansion called binomial expansion. Binomial expansion. Binomial expansion. First write these all. Let's write these all. Okay, just write this is binomial and this is trinomial. And here power n has expansion called binomial expansion. Binomial expansion. Similarly, x plus or minus y plus or minus z power n. Again, n positive integer. We consider only about positive integer powers. Positive integer exponent. Then for rational, irrational, whatever, there can be expansion, but we only consider about positive integers. He also has expansion. Trinomial expansion. Trinomial expansion. Okay, just write all first. And further, let's write few expansions. X plus y to the power 0 equal 1. X plus y to the power 1 equal x plus y. X plus y to the power 2 equal x squared plus 2xy plus y squared. X plus y to the power 3 equal x cubed 3x squared y, 3xy squared y cubed. X plus y to the power 4 equal x to the power 4, 4x cubed y, 6x squared y squared, 4x y cubed y to the power 4. X plus y to the power 5, x to the power 5, 5x to the power 4y, 10x cubed y squared, 10x squared y cube, 5xy to the power 4, y to the power 5. These are general binomial expansions. So if you put minus here, no change. If you put minus here, replace y by minus 5. Then odd powers will affect for that. Here minus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. Then for odd powers, then it will affect that. Okay, these are general binomial expansions. So now see the pattern. Here, when you consider power 3, start with x cube, x squared, x power decreasing, y0, y1, y2, y3, y power increasing. For any term, indices sum is 3. 2 plus 1, 3. 1 plus 2, 3. 3, 3. Then power 4, 4. 3, 2, 1. X power decreasing, y power increasing. Then 3 plus 1, 4. 2 plus 2, 4. Then this is it. Then here these are coefficients. These are coefficients. Coefficients symmetrical 1, 4, 6. Maximum numerical value you obtain at the middle term. When there are two middle terms, coefficients are same and maximum. Coefficients are symmetrical. Coefficients are symmetrical. Then now here power 3, there are 4 terms. Power 4, there are 5 terms. Power 5, there are 6 terms. So those are the properties with binomials. With binomials. These are the binomial coefficients 5, 10, 10, 5, 1 that can be obtained by using Pascal triangle. Okay. Here the way. Here you create a triangle with numbers 1, 2, 1. 1 plus 1, 2. Likewise. Then here 1, 3, 3, 1. 1 plus 2, 3. 2 plus 1, 3. 1 corners always 1. And here 1, 4, 6, 4, 1. And here 1, 5, 10, 10, 5, 1. Okay, this triangle we call Pascal triangle. Pascal triangle. Pascal triangle. This is very easy lesson. Okay, just write these examples also. Write general expansions. Take time. Take time. Okay, now just write. Now just write. An expression with two terms we call a binomial. Write down. An expression with two terms we call binomial. Binomial expression. And with two terms we call a binomial. And the expression with three terms and the expression with three terms is called trinomial. Trinomial expression. Expression with three terms is called trinomial expression. Trinomial expressions. Then, for any integer power of the expression has expansion, then for any integer power of n has expansion, is known as binomial expansion. Is known as binomial expansion. Is known as binomial expansion. General binomial expansions are given above. 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 Every expansion has the following properties. Every expansion has the following properties. Every expansion has the following properties. Okay. Okay, just write property number one. Just write property number one. The expansion x plus y to the power n. The expansion x plus y to the power n has n plus one number of terms. N plus one number of terms. The expansion x plus y to the power n has n plus one number of terms. That is first one. Property number two. Property number two. Start and the power of x decreasing one by one, and the power of x decreasing one by one. And ends with x to the power 0. And ends with x to the power 0. And ends with x to the power 0. X to the power 0. and start with y to the power 0 and ends with y to the power n. Start with y to the power 0 and ends with y to the power n. Y to the power n. And for any term x exponent plus y exponent equal to n. X exponent or index, y exponent or index equal to n. Here 4 plus 1 5, 5, 3 plus 2 5, likewise. Exponent equal to n. That is property number 2. Okay. Then property number 3. Property number 3. Binomial coefficients is obtained by the Pascal triangles. Binomial coefficients are obtained by the Pascal triangle. Binomial coefficient are obtained by the Pascal triangle. By the Pascal triangle. The greatest numerical coefficient is at the middle term. The greatest numerical coefficient is at the middle term. The greatest numerical coefficient is at the middle term. When there are two middle terms, they are maximum and equal. They are maximum and equal. The maximum and equal. Maximum and equal. From the beginning, the numerical value of the coefficient increasing, and then decreasing, The numerical value of the coefficient increasing and then decreasing. And also about the middle term, coefficients are symmetrical. About the middle term, coefficients are symmetrical. Okay, the next property. If n even as on one middle term, n over 2 plus 1 term, when x plus y to the power 2, you put 2 here, 2 over 2 plus 1, second term is the middle term. If n odd has 2 middle terms, n plus 1 over 2 and n plus 3 over 2 terms. These are the middle terms. You consider x plus y to the power 3. There are two middle terms. You put n equal 3 here. 3 plus 1 over 2, second term middle. And 3 plus 3 over 2, fourth again, third one term middle term. There are two middle terms. Write them all. Okay, you see examples. X plus y to the power. Let's see this one. To the power 4. 1, 2, 3, 4, 5 times there. 5 times there. N equal 4. Then middle term. 4 divided by 2 plus 1. Even. It is third, no? Third term. 1, 2, 3. Here the middle term. Third term. You consider to the power 10. 10. There are 11 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 terms. Then N11, N10, given. It has only one middle term. In middle term, 10 over 2 plus 1. Sixth term. 1, 2, 3, 4, 5, 6. Here the middle term. Okay, likewise you can find middle term. You consider to the power 11. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N odd. N equal 11. It is odd. Then there are two middle terms. Middle terms. Here 11 plus 1 over 2 equals 6, no? 6th. 1, 2, 3, 4, 5, 6. Here one middle term. And 11 plus 3 over 2. 7. Then next term also middle term. Middle term. Those are middle terms. Write examples. Write examples. Take time. Take a little time further. Okay, time's enough. Okay, now better to remember these trinomial expansions. X plus y plus z to the power 2 expansion. Take x plus y plus z to the power 2. Take these two as p. X plus p to the power 2. Expand x squared plus 2px plus p squared. Do with me. X squared plus 2 y plus z. Replace now p by y plus z. Y plus z to the power 2. Simplify. X squared 2xy 2zx y squared plus 2yz plus z squared for the binomial here. Now write the pattern x squared plus y squared plus z squared, x squared plus y squared plus z squared, 2xy, 2yz, 2xz. Here the expansion. Similarly, x plus y minus z squared. To obtain, replace y by z by minus z. X squared plus y squared plus minus z squared. 2xy, 2y minus z, 2x minus z. Replace z by minus z. Now get the form. X squared plus y squared plus z squared. 2xy. Here these two plus 2xy. 2yz minus 2xz minus 2yz, 2xz. These are general trinomial expressions. These need to be remembered directly. Okay, write them all again. And then trinomials. Take time. Take a little time further. Okay, time's enough. Time's enough. Now, this Pascal triangle technique basically that applicable for some less integer powers, but for high integer powers, then Pascal triangle not applicable. That is not practical. Then there's a theorem we call binomial theorem. Binomial theorem. Just write down. For higher power of higher value of the exponent, for the higher power of the exponent, this Pascal triangle technique Therefore, there's a theorem called binomial theorem. There's a theorem called binomial theorem. There's a theorem called binomial theorem. Now see this one, x plus y to the power n, where n positive integer. N positive integer. Then x plus y to the power n is equal to x plus y to the power n equal to nc0 x to the power n plus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y squared plus nc3 x to the power n minus 3 y cubed. It goes like that. Check this one. Start with x to the power n. X power decreasing 1 by 1. Y power increasing 1 by 1. Then the order is okay. And the last term will be NCN y to the power n. NCN y to the power n. Okay. Okay, these are called binomial coefficients. NC0 coefficients. Binomial coefficients. These are binomial coefficients. Then there's simplification. A simplification we call NCR equal n factorial divided by n minus r factorial divided by r factorial. Factorial n minus r factorial r factorial. 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 Okay, now see this. Here these are we call factorials. Here 3 factorial, 3 into 2 into 1 factorial, 4 into 3 into 2 into 1. These are factorials. Factorials mean product from 1 to that number. That only applicable for positive integers only. But here we say 0 factorial 1, that is definition. Then 4 factorial 4 into 3 into 2 into 1. Then when you divide this one, you get 3 factorial. When you divide by 2, we get 2 factorial. When you divide by 2, we get 1 factorial. When we divide by 1, we get 0 factorial. We say that is 1. These are factorials. Anyhow, this theorem we call binomial theorem. Binomial theorem. Take a little time to write all. Just write all. This is we call binomial theorem. This is we call binomial theorem. Take time. Take the time further. Take a little time. Okay, now see. Now see the pattern. Here we call first term. Here we call second term. Here we call third term. And here we call fourth term. And here we call n plus 1 term. N plus 1 term. Then 1, 2, 3, 4, likewise. There are terms. Then here you consider rth term. Rth term we call general term. We call general term. We denote by TR. We denote by TR. Rth term. See this first term NC0, second term NC1, third term NC2, fourth term NC3. Then rth term will be NCR minus 1. No? Take it again. First term NC0, second term NC1, third term NC2, fourth term NC3. Then rth term NCR minus 1. X to the power n, x to the power n minus 1, n minus 1, x to the power n minus 2, n minus 3, and here x to the power n minus r minus 1. Here the order. Then y power, y to the power 2, y to the power 3, likewise. Then here y to the power r minus 1. This is we call general term. For any expansion, we need to write this general term. Before doing the action, we need to write general term. This is called general term. Okay. Then same series, x plus y to the power n can be written as sigma r equal 1 to n tr. Then sigma r equal 1 to n plus 1. Okay. There are n plus 1 number of terms, n plus 1 number of terms. Then r equal 1 to n plus 1 tr NCR minus 1 x to the power n minus r minus 1 y to the power r minus 1. Okay. Same expansion we can write in this way. Okay. Just write on. Again you write this expansion. Again you write and write general term. And by the side write same expansion using sigma notation. Take time. Take time. Take time. Take your time. Okay. Now see few expansions with binomial theorem. I see few expansions with binomial theorem and how to write general term in each expansion. Write this question, write this question, write this one. Write binomial expansion for the following cases. Write binomial expansion for the following cases. And also write general term. And also write general term. Now x plus y to the power 3, you write 3c0, x cubed, 3c1, x square y, 3c2, xy squared, 3c3, y cube. Okay, like guys, you can write x plus 2y to the power 4, 4c0, x to the power 4, 4c1, x to the power 3y, 2y, 4c2, x squared, 2y squared, 4c3, x 2y cubed, 4c4, 2y to the power 4. Okay, see the pattern. And 2x minus half to the power 5. Now see the pattern. 5c0, 2x to the power 5, 5c1, 2x to the power 4, minus half, 5c2, 2x to the power 3, minus half square, 5c3, 2x to the power 2, minus half cube, 5c4, 2x, minus half to the power 4, 5c5, minus half to the power 5. Likewise, you can write expansions. Then 2x plus 3y to the power 10, 10c0, 2x to the power 10, 10c1, 2x to the power 9, 3y, 10c2, 2x to the power 8, 3y squared, 2x power decreasing, 3y power increasing. No need to write all. See the pattern. Then 10, C 10, 2y to the power 10. Here the binomial expansion. This is the binomial expansion. Okay. Just write examples. Just write examples. Later we will see how to write general term. Take time. Take time. Take little time. Okay. Now let's see how to write general term. First one, general term TR. NC R minus 1 x to the power n minus R minus 1 y to the power R minus 1 is the general term. You need to remember this. So now here n value given 3. You put 3. X value x, y value y, and no change. Then you write simplest form. 3c r minus 1 x to the power 4 minus r y to the power r minus 1. This is the general term. General term. Then second one, here this one. NC r minus 1, x to the power n minus r minus 1, y to the power r minus 1. Now, here n mean 4, x mean x, y mean 2y. Simplify. 4c r minus 1, x to the power 5 minus r, times 2 to the power r minus 1, x to the power 5 minus r, y to the power r minus 1. Okay. Third one, here tr, nc r minus 1, x to the power n minus r minus 1, y to the power r minus 1, then n value 5, x value 2x, here 5, y value minus half. Simplify. 5c r minus 1, 2 to the power, here 6 minus r, here minus half to the power r minus 1. Don't remove minus sign. Then x to the power 6 minus r. And here this part we call coefficient. No? Coefficient. And here x. Here coefficient. Numerical value is the coefficient. Fourth one. Here you remember NC r minus 1, x to the power n minus r minus 1, y to the power r minus 1. Now here n 10, x 2x, y 3y. Ten c r minus 1, 2 to the power 11 minus r, 3 to the power r minus 1. Better to write numerical terms together. X to the power 11 minus r, y to the power r minus 1. Here it is. Okay. Just write the general terms also. Take time. Take time. Take time. Take time. Take time. Okay, that is general term. Then this general term, very important one, that represent every term in the series. Every term in the series. Every term in the expansion. Okay. Now you write these expansions. Okay, write these expansions. Okay, write expansions soon. Write soon. Take time. Write general term also. Take time. No need to write every term. Just write first two and last, first three and last one. 4C0, 5 to the power 4. 4C1, 5 to the power 3, 4x bar. Then here, last term, 4C4, 4x bar to the power 4. Here 6C0, a to the power 6. 6C1, a to the power 5, 3x. 6C6, 3x to the power 6. 7C0, x to the power 7. 7C1, x to the power 6, 1 of x. 7C2, x to the power 5, 1 of x squared. Write down in the pattern. 7C7, 1 of x to the power 7. 6C0, x of 2 to the power 6. 6C1, x of 2 to the power 5, 2 over y. 6C6, 2 over y to the power 6. 10C0, 10C1, minus half x to the power 1. 10C2, minus half x to the power 2. 10C10, minus half x to the power 10. 5C0, 2x to the power 5. 5C1, 2x to the power 4, 3y. 5C2, 2x to the power 3, 3y squared. 5C5, 3y to the power 5, 3y to the power 5. 5C0, 2x to the power 5. 5C1, 2x to the power 4, 1 of x. 5C5, 5. Here, this is binomial. It is trinomial, but you convert into binomial. 1 plus y, power 3, no? Then we can write 1 plus 3y plus 3y squared plus y cube. Here, first expansion. Thereafter, you expand here this one and this, and we can rearrange the terms. No? Then write all. Just write all. Take time. Take time. Take time. Take time. Okay. Now let's write general terms. Let's write general terms. You remember the pattern and write general term. 4c r minus 1, 5 to the power 5 minus r, 4x bar to the power r minus 1. Here tr 6c r minus 1, a to the power 6 minus r minus 1, that means 7 minus r, 3x to the power r minus 1. 7c r minus 1, x to the power 8 minus r, 1 over x to the power r minus 1. Tr 6c x over 2 to the power 7 minus r 2 over y to the power r minus 1. Okay. 10c r minus 1, 1 power, okay. Then 1 to the power 11 minus r minus half x to the power r minus 1. 5c r minus 1, 2x to the power 6 minus r, 3y to the power r minus 1. 5c r minus 1, 2x to the power 6 minus r. You subtract these two right here. 5 minus r minus 1, 6 minus r. Minus 1 over x to the power r minus 1. You take these two together. 3c r minus 1, 1 to the power 3 minus r minus 1, 4 minus r, x plus x squared to the power r minus 1. Here's general term. You can take any two terms together. Write general terms. Take time. Take time. Okay. Now put a stomach and write down. Press stomach and write down. By using the general term, by using the general term, any term in the series can be deduced. By using the general term, any term in the expansion can be deduced. Any term in the expansion can be deduced. Say example, 2x squared plus 1 over x to the power 10. Then TR 10CR minus 1, 2x squared, 11 minus R, 1 over x to the power R minus 1. Here general term. If we need fifth term, let R equal 5. Then T5, 10C 5 minus 1, 2x squared, 11 minus 5, 1 over x to the power 5 minus 1. Then 10C4, 2 to the power 6, x to the power 2, 6, 12, 1 over x to the power 4. 10C4, 2 to the power 6, x to the power 8. Okay, this is called fifth term. Likewise, you can deduce any term. Okay, you can deduce any term. And here you put this note by side. NCR we write N R within this bracket. Okay, here these are notations. Then N factorial, just another notation. And here another notation. N factorial we write this way. Then example 2. 2x plus 3y to the power 4, 8. TR 8CR minus 1, 2x to the power 8 minus R minus 1, 3y to the power R minus 1. Then 8CR minus 1, 2x to the power 9 minus R, 3y to the power R minus 1. We need third term. Let R equal 3. Then T3 will be, substitute 3 here. 8C3 minus 1, 9 minus 3, AC2, 2x to the power 6, 3y to the power 2. Here third term. Third term. Okay. Just write examples. Take time. Okay. Now likewise, you can reduce any term. First you write R term, then substitute R value as required. Okay. Now let's move further. Just write. Next question. Find term independent of x for the following expansions. Find term independent of for the following expansions. Find term independent of x for the following expansions. Okay, I'll do example. X plus 1 over 6 to the power 1, x plus 1 over x to the power 6. When finding term independent of x, you first get general term. 6c r minus 1, x to the power 6 minus r minus 1, 1 over x to the power r minus 1. Simplify. 6c r minus 1, x to the power 7 minus r, 1 over x to the power r minus 1, 6c r minus 1, x to the power 7 minus r minus 1. Here, division, then take as subtraction. X to the power 8 minus 2r. 8 minus 2r. Now, term independent of x means no x term. Term x. No x term. No x term. Therefore, x power will be 0. Otherwise, there will be x term. Therefore, power of x is 0. Then power of x. Then r value 4. Therefore, say fourth term is independent of x is independent of x. Then you write T4. Here take R4, 6C3, x to the power 0. Then that's only 6C3 only. Here fourth term, 6C3 only. You can further simplify, okay? Just do that example. Take time. Take time. Okay, let's do another one. Let's do another one. Question 2. X squared plus 1 over x to the power 9. X squared plus 1 over x to the power 9. First write general term. TR. 9cr minus 1 x squared to the power 9 minus r minus 1 1 over x to the power r minus 1. Now simplify. Twenty minus 2r minus r minus 1. 21 minus 3r. Now term independent of 21 minus 3r equals 0. Now r value equals 7. Seventh term. Now you write T7, substitute here. 9c6 x to the power 0. 9c6 only, no x term here. Do example. Do example. Third one. 2x minus 1 of x to the power 10. Do with me. 5tr. 10cr minus 1, 2x to the power 10 minus r minus 1, minus 1 of x to the power r minus 1. 10cr minus 1, 2 to the power 11 minus r, minus 1 to the power r minus 1. X to the power 11 minus r minus 1. Simplify. 10cr minus 1, 2 to the power 11 minus r, minus 1 to the power r minus 1. X to the power 12 minus 2r. Then r value equal 12 minus 2r 0. R value equal 6. R value 6. Therefore, sixth term. Independent of x. Sixth term independent of x. Then you write T6. 10c5. 2 to the power 5. Minus 1 to the power 4. Then we can remove minus now. Here sixth term. That is third one. Okay, that's all about binomial for today. So we have done a lot of things about binomials. Then next session we will do furthermore binomial theorem relations, coefficient relations, and a lot of things we need to discuss. So within another few days, we can complete this lesson. Then let's start for today. Okay, then bye.